Alright, let's investigate some linear inequalities, and also want to point out kind of why some of the rules are how they are and the notations are the way that they are. So let's start with something really basic. How about 1 plus x is less than 4? Alright, well, most of the time, all the time actually, besides one small in particular, which we'll look at next, you treat your inequality just like it were an equal. Right? If this were 1 plus x equals 4, I simply take away 1 on both sides and have x is less than 3. Right? Or x equals 3 if it were an equal. Now with inequalities though, they're going to ask for different ways of writing the solution. First off, the set builder notation, I'm just going to put SBN. It's kind of strange for now. In future math it has its purpose, but we draw a brace, which I'm horrible at, and then whatever variable we're using, then this bar, and this bar simply means such that. So the set is x such that, and then you simply write your solution in here, such that x is less than 3. Alright, pretty trivial. Take whatever this is, put it here, be sure you put your variable, and this bar surrounded in braces. Right? X is less than 3 in a graph. I'm not going to fill in everything, we'll just say 3 is here. Right? So 2, 1, and so forth, 4 and 5 and so forth. Anyways, when we have this less than, okay, either less than or a greater than, two ways of doing it. You could either use parentheses or we use an open dot. Okay, more on that in just a second. If we have lines underneath, so the less than or equal or greater than or equal, we use brackets or we fill in with a solid dot. Right? There's no line underneath this for our solution. X is less than 3. So probably, when you first did this, you learned you put it, oh shoot, I messed up. That totally meant to be an open circle. Fix that really quick. Okay, so you put an open circle, and then less than 3 would be all these values this way, right? So it would shade to the left. Typically, in college algebra and beyond, we get rid of this whole open dot thing, and what we do is parentheses. So what we use is a parenthesis here on 3, and shading is the same as before, shade to the left. Now, why is this preferred? It's because when we go to do interval notation, I'm just going to say IN. Oops, eraser, come on. So with interval notation, if we have this graph, we simply write what appears here with the parentheses or brackets and whatnot, and put it in this notation. So this graph is going left forever, right? It's going forever left, negative infinity, never stops. So when we write this in interval notation, we write our leftmost point, well, infinity is not a point, but get it, up to 3, and we use parentheses because we do not include 3 because it were a less than, not a less than or equal. Also, you never use a bracket around infinity because you can't include infinity, it's forever going, right? So basic inequality example, mostly I wanted this example to point out these different methods of writing our solution: set builder notation, and graph and interval notation. Alright, next example. Let's do, instead of 1 plus x, let's do 1 minus x. And I'm going to go ahead and put a line underneath for this one, just to have that example. Alright, again, if this were an equal, what would we do? We'd subtract 1 on both sides, right? Negative x less than or equal to 3. But at this point, if this were an equal, we'd simply divide by -1 and have x equals -3. However, with inequalities, anytime you multiply or divide by a negative, the sign has to flip. You have to reverse the sign. So instead of less than or equal, we now have greater than or equal to. Okay. Set builder notation again. Brace x such that x greater or equal to -3. Done. The graph. Okay, we're at -3 now, so here's -2, -1, and so forth. Okay, our old way, this has a line underneath, right? So we would do solid dot. Greater than means we're shading to the right. But more common in algebra and beyond, we use brackets. Okay, greater or equal to -3, we're doing a bracket on -3, opening to the right because it's shaded to the right. And that helps us because when we go to do interval notation, we're simply mimicking this graph, right? We have a bracket, the lowest value is -3, which is included, that's why we did a bracket, and this thing shoots off forever to the sunset, infinity, right? Again, parenthesis on infinity, you never include infinity, always parenthesis. Jumping back a second. I mean, I kind of just said, oh, the rule is you divide by negative and you flip the sign, right? But, like, why? Hated rules without really understanding. I mean, hopefully you just remember to do that simple enough rule. It is what it is. But let's take a look at this. Let's go back to this step. Oops. -x less than or equal to 3, right? Okay. Here's why. I'm going to go ahead and move this x, right? It's a negative. I'm not going to multiply or divide by negative. I'm adding. I'm going to add this x to the other side. If we did that, we would then have 0 less than or equal to 3 plus x, right? Now solving for x, again, I'm not going to multiply or divide by negative. Simply using addition and subtraction, I could have this to rewritten as -3 is less than or equal to x. Well, again, using like what it is an inequality, this alligator, Pac-Man, right, whatever you want to draw, it's eating the x. So if I wanted to rewrite this, I could, because, you know, we like x's on the left, and I don't know why, it really doesn't matter. But these are the same. Right, -3 less than or equal to x is the same thing as saying x is greater or equal to -3. So why do we change the sign? Well, it's just a shortcut, right? Rather than getting x to always be positive as we did here and having to rewrite it, it's what works. And that's why it is how it is. Okay, that's most of the basics of our linear inequalities. Let's take a look at a compound inequality. So next example, compound inequality. How about something simple just to demonstrate what's going on. Alright, again, this rule basically says if whatever we do to one side, we do the other side the equal, right? Well, we have an inequality and we actually have two of them, or three parts, I should say. Still, I'm trying to isolate x, so I'm going to subtract 5. Now, can't just subtract 5 here, I have to subtract 5 on all three parts of this compound inequality. 2 is less than x is less than 6. Really quick again, like, why do we do that? Well, this compound inequality at the start really just says 7 is less than x plus 5, right? I'm taking this first piece. But then we also have x plus 5 is less than 11, right? This second piece. So we have to work both of those. Both of those are true. And we could see, if we did this first one, subtract 5 on both sides, we'd have 2 less than x, right, which is here. And the second one, subtract 5 on both sides, x is less than 6, which is here. So it doesn't matter if you prefer to split it into 2, that's fine. If you want to do it all at once with these compound inequalities, that works as well. Quick again, the set builder notation, right? Brace x such that we simply write our answer. Done. In a graph, notice x is between 2 and 6. I'm not going to fill in all these numbers, just between 2 and 6. So I know everything in here meets the solutions, right? Well, there are no lines underneath the inequality. It's just a less than. So we do parentheses, a little off here. Parentheses, 2x is between 2 and 6. And that way when we go down to this our interval notation, right, I could simply copy this graph, parenthesis 2 comma 6 parenthesis. This is not a point. It's not the point 2, 6. It's not x is 2, y is 6. Interval notation describes our solutions. X is between 2 and 6. All right. Couple quick like weird examples. Sometimes, like we could get no solution or we could get an infinite amount of solutions. Like anything could possibly work. So how about we have something like this: 3x minus 2 minus 3x less than, let's say 1 plus 3x minus 7. Okay. Again, treat it as if it were an equal unless you divide by a negative. So distribute everything, combine like terms. We'd have 12x minus 8 minus 3x less than 3 plus 9x minus 7. Combining like terms, 12x minus 3x is 9x minus 8 less than, here we'd have 9x, 3 and negative 7 minus 4. Once we subtract 9x on both sides, right, these are gone, we simply have negative 8 less than negative 4. Yeah, like that's true, right? Negative 8 is in fact less than negative 4. But what does that mean? Well, if you end with a true statement, that simply means x could be anything. X could be anything, any real number, right? From negative infinity to common infinity, in interval notation, that is. Any number would satisfy this inequality. Anytime all the variables cancel and you simply end in a true statement, that's your solution. Well, what if you end in a false statement? Let's do one more example like that. So how about 3 parenthesis x minus 8, negative 2, 10 minus x, greater than 5 parenthesis x minus 1. Okay. Let's distribute again. So we have 3x minus 24 minus 20 plus 2x greater than 5x minus 5. Okay, combining like terms, 3x, 2x, it's 5x, negative 24, negative 20, negative 44. greater than 5x minus 5. Again, subtracting 5x on both sides, these are going to cancel, and we have something negative 44 greater than negative 5. No, that is not true, right? That's false. Negative 44 is not greater than negative 5. If you end up with a false statement, what does that mean? It means no solution. Okay, there is no x that would ever make this inequality true. It's empty set, no solution.